some more trigonometric equations. We have 2 sine of x plus cosecant of x. Now, if you have an equation where you have different trig functions, you must change them into the same. At least try to change them into the same. So we have cosecant and sine here. I'm going to change the cosecant into a sine function. 2 sine of x, and of course that is 1 over sine of x, and that's equal to 0. Now, just with any other equation where we have a denominator, we want to see if we can multiply by the least common denominator and then reduce and see what happens. So I'm multiplying both sides by the sine of x, which leaves me with 2 sine squared of x plus, you can see that this sine and this sine reduced to 1 equals still 0. So I need to isolate the sine squared of x by subtracting 1 from either side. 2 sine squared of x is negative 1. And then divide by 2. Sine squared of x equals negative 1/2. Oh, what's going on here? If you now were to take the square root, you would have the sine of x is some kind of imaginary number, because you cannot take the square root of a negative 1/2 unless it's imaginary. It would be plus minus square root of 2 over 2. Let me write the I here. And of course that is something we cannot graph. That is an imaginary number. So when you get an imaginary number, what does that mean? That means no solution. You have no solution here to this problem. Okay, well, let's take a look at the next one. So we have the square root of 3 cosecant minus 2. Let's try to isolate the cosecant by adding 2. Square root of 3 is the cosecant of x equals 2. Divide by the square root of 3. And we have the cosecant. Cosecant of x equals 2 square root of 3. Now, we may not be all that familiar with the cosecant, so what you really can do is the reciprocal of the cosecant is the sine, so I can write that as 1 over sine of x equals 2 square root of 2. And then I flip, square root of 3 I meant. Now I flip both. That gives me the sine of x equals the square root of 3 over 2. So for which angles is the sine square root of 3 over 2? And if you look at your unit circle, you will find that the angle is pi over 3 in quadrant 1 because it's positive. And since we don't have a restriction here on our domain, we also have to say plus 2n pi times. So this angle repeats every 2 pi times. Now where else, for which angle is the sine also square root of 3 over 2? It's positive. That would be in quadrant 2. And in quadrant 2, the angle is 2 pi over 3, and we have to, of course, add 2n pi times to it. That's how you find the solutions for trigonometric equations.